Hello Internet and welcome to a new episode of Workshop Reports. Today I want to show how to build a lathe, or better a mini lathe. I need a lathe for small or medium-sized rounded workpieces. I also want to use the device for other tasks, for example as a disc sander. As the material basis, I have used a lot of inexpensive materials. For example, fiberboard, chipboard and plywood. And the lathe is driven by an old drill with variable speed setting. It is good advice to prepare your build. Create a bill of materials and think through the individual work steps in before. There are several good examples out in the internet, among others, for example, the build by the great Izzy Swan, or the video from Jack Holing, or Matthias Wandel, which is very interesting ideas, and many other more. These have served me as a template, and I will prepare some links in the video description down below. I had a lot of fun during the creation of the machine and my first turning experiences, and hope the video is also fun for you. So let's build a mini lathe. I divided the construction of the lathe into 15 individual working steps. In the video description, you will find the individual start times of the working steps in the video. Here you can see a schematic animation how the lathe was built. First, you have the base plate, on top the two guide rails made out of MDF stripes on the left and the right side. In between the headstock and the tailstock, with their sliding bottom plates and the spindle and the bearing. Finally, the cross slide and the tool rest, and the base construction to fix the drill. In the animation you can see how everything fits together. Now let's have a look into the individual working steps. I used the kitchen worktop as a base plate for the lathe. I bought some cheap rest parts from my local hardware store for a few euros. The worktop is made of 40mm chipboard, LDF, and is sturdy and heavy, and fits very well as a substructure for the construction. As a guide for the headstock and tailstock, I just take 4 MDF stripes with different width. The wider bar is glued to the narrower bar, screwed and glued to the right and left on the base plate. Thus we have a very stable guide rail to guide the headstock, the tailstock and the cross slide, or other parts we want to mount on the base plate. Use the base plate for the headstock and tailstock as spacers between the guide rails. Add a piece of paper around the base plate to create extra space for the base plate to slide. I used a stripe of isolation tape on one side to create some extra space between the guide rails. Create a head and a tailstock. For a high stability of the headstock and tailstock, I glued and screwed 3 MDF fiberboard boards together. Screw and glue the base plate of the headstock and the tailstock. The width of the MDF boards depends on the width of the gap of the guide rail. Create a spindle. I used a 10mm threaded rod for the headstock and tailstock spindle. Cut the threaded rod to your required size. Make sure the spindle parts are long enough to fit your requirements. For example, my tailstock spindle in the video is a bit too short and I have to create another one to give me more room to work with. Also, I recommend to use a thicker threaded rod to give you more stability and less vibration. If your drill chuck supports 30 or 60mm, go and pick a thicker threaded rod and combine them with the fitting bearings. The holes for the bearings of the spindle are drilled in the inside of the headstock and the tailstock. To drill the holes, I use a suitable Forstner drill. Drill the holes for the bearings only on the inside of the head and tailstock. Drill the hole for the spindle into the headstock and tailstock. Use the center point of the Forstner drill as the center point to drill the holes for the spindle. Use a 10 mm wood drill with a drill bit tip and drill nearly all the way through the head and tailstock until the tip appears on the other side. Use the small hole from the drill bit tip as the center point for the Forstner drill to drill the hole for the bearing on the other side of the head and tailstock. Afterwards, use a 12 mm wood drill to widen the hole and give the spindle more room to turn. Insert the bearings into the head and the tailstock. Check that the axes are aligned at a 90-degree angle. Insert threaded nuts into the base plates. The holes for the threaded nuts must be drilled into the base plates, and the nuts are screwed in with a 90-degree angle. Here I use the appropriate threaded nuts for the 10 mm threaded rod. 9. Create a plywood cross slide. The cross slide is mounted on a sliding base plate, just like the head and the tailstock. 10. Create a tool rest with adjustable height. I took a hinge and fastened it to a wooden block with screws. This allows me to easily adjust the height and orientation to the workpiece. "11. Create a substructure construction for the drill. The axis of the drill must be at the same height as the axis of the spindle. The subconstruction should be moved and fastened with a screw. The most important thing here is that the axis of the drill must be at the same height as the axis of the spindle. The subconstruction should be moved and fastened with a screw. "12. Fasten the drill with an insulated pipe clamp. The rubber insulation of the insulated pipe clamp reduces noise and vibration during turning. "13. Make a lathe chuck or a faceplate. There are different ways to create a lathe chuck or a faceplate. Here I show two simple approaches. On the one side, using a T-nut with reversed tips. And on the other side, a disc dowel or M16G style bulldog single blade with teeth in combination with a T-nut. Assemble the lathe. Okay, everything put together properly. Now it's time to sharpen the wood turning chisels and find out how to wood turning. I had a lot of fun with the creation of the machine and the turning of the workpieces. And hopefully you had some fun watching the video and maybe with your own built lathe. I will add an additional video about different inexpensive ways to build a lathe chuck and faceplates. If you are interested in the topic, come back to my channel and follow the progress. If you have questions, feel free to ask and put them in the comment section. Well, if you have a good idea, let me know. If possible, I will add this to my lathe or to my projects. I would appreciate if you push the like button and click the subscribe button to follow the design and build story. Have a good time and stay tuned.